We're going to look at some simple harmonic motion examples, and in each case you've got to work out the time period for the oscillation. You do this by counting 10 oscillations and then dividing the time by 10 in order to get the time for one oscillation. We're going to start with a simple pendulum. So all I've got here is a stone on the end of a piece of string. And if I start it oscillating, we can then time. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See if you can work out the time for one oscillation. The next one is a spring pendulum, and again we're going to do 10 oscillations. So I can set it going and start the stopwatch when it's at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, work out the time for one oscillation. This is a torsion pendulum. It rotates, and I've got an optical pin here which I've painted white so you can see it a bit clearer. And let's see what its period of oscillation is. Set it going, start the stopwatch. 1, 2, 3, 4, 5. This is a compound pendulum, which is a solid bar. We'll try and do 10 of these. And I'll start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is really fiddly to do. It's an oscillating test tube which is upside down filled with air in a beaker of water. We'll try and do 5. So I'll lift it up and press go. 1, 2, 3, 4, 5. See if you can work out the time for one oscillation. This is our poor light beam galvanometer that I'm going to abuse a little bit. And what I'm going to do is to make the light on it oscillate very, very fast. And the way I'm going to do it is to put a large current by just touching it to this battery. Now it's going to go right off scale, so we're going to have to time it as it comes through the 0, going the same way each time. So we'll set it going, start it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See if you can work out the time for one oscillation. Let's have a look at a ball oscillating in a bowl. So I'll set it going and then start the clock. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you work out the time for one oscillation?